As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I am joining Shobhit University. What about you?
Very good morning to all the participants from India and abroad. Shobhit Institute of Engineering and Technology Meerut, deemed to be university, and its Centers of Excellence, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications, in association with African Asian Rural Development Organization, ARDO, New Delhi, organized this weekly international webinar series on open source digital technologies towards self-reliant India, Atmanirbhar Bharat, 3rd July 2021. On behalf of the Honorable Chancellor, His Excellency the Secretary General, ARDO, Honorable Vice Chancellor, the faculty members of the university, and on my behalf, and as Professor Emeritus and Chairman of the Centers of Excellence, Center for Agricultural Informatics and E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, and Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications. Welcome our guest speaker of today's webinar, Mr. Guntuku Prasad, Senior Technical Director and Head of CollabCAD Division, National Informatics Center, Ministry of Electronics and Information Technology, Government of India, New Delhi. Today's topic is Industry 4.0 in Micro, Small and Medium Enterprises, MSMEs. Benefits of indigenously developed CollabCAD, 3D CAD, and PLM software from National Informatics Center, Product Lifecycle Management Software, PLM. Mr. Guntuku Prasad, for your information and also to the participants of this international webinar series, under this international webinar series, these two centers of excellence, Center for Informatics Development Solutions and Application and Center for Industry 4.0 Technology Studies and Application, have organized 34 lectures so far on the titles Open Technologies to Provision, Simple and Economical IT Infrastructure, delivered by Dr. P. Balasubramanian on 12th September 2020. A roadmap for students using free and open source software and reaching goals of Atmanirbhar Bharat. Open source software and industrial IoTs for SMEs by Dr. H.K. Suhas on 25th September 2020. Free and open source software adoption, public business models, open data platform for smart digital government, technology imperatives made in India for self-reliance by Dr. K.K. Bajaj, Edge Artificial Intelligence, Data Governance for Self-Reliant India, Digital India Transforming Governance and Society by Dr. Y.K. Sharma, India's email service citizen@indiamail.com in 22 constitutionally recognized language by Dr. Seema Khanna, Ecosystem for Digital Transformation by Shri J. Satyanarayana, IAS retired, former Secretary to the Government of India, Education System Cyber Critical Infrastructure, Seizing Opportunities in Open Innovation and Value Creation Network in the Digital World for Self-Reliant Economy by Dr. Jabamalai Vinanti Arachi, former Principal Advisor to the Director General Unit of Vienna. Ensuring food safety and compliance through technology. Digital India, urgent need for semiconductor manufacturing in India. Technology investment in agriculture value chain, role of foreign direct investments. Entrepreneurship and skill development, artificial intelligence, AI design pathways, The rise of platform economy, revisiting value chain governance. Professor Dr. Charu Malhotra from Indian Institute of Public Administration, Delhi. The era of automation, industrial robotics and industry 4.0, Indo-German perspective of technology transfer, skill gap analysis and opportunities. Role of artificial intelligence in healthcare, current developments in diagnosis and vaccine research. Digital agri-tech and agri-startup perspective, health informatics network value chain, e-health systems and beyond, leveraging emerging technology for ensuring transparent and traceable agri and food supply chain. Unleash the power of citizen development for enterprise software development. E-governance models towards sustained quality service to citizen backed up by technology. Indian MSMEs to adopt Industry 4.0 technology capabilities, urgent need for mentorship and accelerator program. Building public digital platform using microservices and APIs. Health informatics network value chain, early childhood development and learning. Health informatics network value chain, clinical artificial intelligence, interface between machine learning and health informatics. Health informatics network value chain, importance of social medicine and health, community health in times of emergency by Professor Sankamitra Shil Acharya of Jawaharlal Nehru University. Gravity filter, G-filter, a simple low-cost solution for drinking water treatment in rural India. Open source GovTech startups empowering growth with automation, digital transformation in small enterprises and small businesses, India, challenges and opportunities. National Digital Twin Program, need for a robust geospatial infrastructure by Mr. Vishnu Chandra, Deputy Director General, National Informatics Center. Today is the 35th edition of this very important webinar series. We will have the talk by our guest speaker, Mr. Guntuku Prasad, Senior Technical Director from National Informatics Center, on the topic Industry 4.0 in MSMEs, benefits of indigenously developed CollabCAD, 3D CAD and Project Lifecycle Management Software from NIC. Dear participants, please see the keywords Industry 4.0, micro, small and medium enterprises, MSMEs, CollabCAD, 3D CAD software, PLM software, National Informatics Center, and indigenously developed software. It's very appropriate for the international webinar series on open source digital technologies for self-reliant India. To recall in this webinar series, the university has hosted about 11 talks related to digital transformation in MSMEs. One by Dr. Balasubramanian and open technologies to provision simple and economical IT infrastructure. Another by Dr. H.K. Suhas on open source software and industrial IoTs. And Dr. Bajaj, he talked on technology imperatives made in India for self-reliance. G. J. Satyanarayana, former Secretary to the Government of India, talked on ecosystem architecture for digital transformation. Dr. Jabamalai Vinanchi Arachi talked on seizing opportunities in open innovation and value creation network in the digital network for self-reliant economy. Professor Charu Malhotra from Indian Institute of Public Administration talked on rise of platform economy, revisiting value chain governance. Mr. Vangabandhu Venkata Nagaraju talked on era of automation, industrial robotics and industry 4.0, how to bring in Indo-German perspective of technology transfer, skill gap analysis and opportunities. Mr. Alagiri Govindaswamy and Mr. Alok Varshane talked on Indian MSMEs to adapt Industry 4.0 technology capabilities, urgent need for mentorship and accelerator program. Based on this talk, and in universities building up an MBA program for Industry 4.0 for SMEs. And then Mr. Prakash Ramaswamy talked on open source GovTech startups empowering growth with automation. And Mr. R.K. Jayabalan, founder and CEO Consortium, talked on digital transformation in small enterprises and small businesses of India. And then Mr. Vishnu Chandra talked a very effective address on National Digital Twin Program. The country needs a robust geospatial infrastructure, which is not existing in this country. And Atmanirbhar Bharat is the road ahead. It is a vision of Honorable Prime Minister of India, Shri Narendra Modi, of making India a self-reliant nation, rested on 5 pillars, 5 I's: intent, inclusion, investment, infrastructure, and innovation, and based on 5 pillars: economy for quantum jump, infrastructure, one that represents modern India, system, 21st century technology driven, demand, whereby strength of our demand and supply chain should be utilized to full capacity. And the last one is vibrant demography, the source of energy for self-reliant India. This was announced on 15th May 2020. Vocal for local to make it global, a demand-based economy system which is self-producing and self-consuming, giving the clarion call on make in India, make for India, make by India, and make for global. These reforms have been announced systematically, planned, integrated, interconnected, and futuristic for creating strong enterprises, generating employment, and robust supply chain. On 5th March 2021, Honorable Prime Minister in a seminar on productivity linked incentive scheme for 13 crore sectors, he mentioned that the PLI 6 scheme, that's a productivity linked scheme, would make a major impact to country's MSME ecosystem by creating an anchor units in every sector that will need a new supplier base across the entire value chain. And this industry to innovate according to the needs of the fast changing world, increase our participation in R&D, upgrading the manpower skills and the use of new technology. He said that we have to attract cutting edge technology and maximum investment in the sectors related to our core competence. Digital world is the rise of platform economy, and which applies big data, new algorithms, artificial intelligence, blockchain technology, open APIs, and cloud computing. And it is emerging, and digital ecosystems are essential for digital transformation in the digital world. Today we talk about Industry 4.0, and tomorrow is India's 5.0, and India has to acquire these capabilities, has to operationalize it. The key core technologies are categorized as A, B, C, D, E. A is artificial intelligence, analytics and operations research. B is blockchain, and C is cloud, IoT, and 5G communications, and big data and ecosystems. Digital transformation, is possible by building public digital platforms using microservices and APIs. Digital twins are realistic digital representation of physical assets. A digital twin is a virtual representation that serves as the real-time digital counterpart of a physical object or a process. And the digital twin ecosystems for data exchange, it uses technologies like IoT, big data, artificial intelligence, 5G, 4G, and cloud computing. And the emerging technologies which are being used in this process are 3D printing, including additive manufacturing, advanced material, advanced analytics, advanced robotics and cognitive automation, and artificial intelligence, blockchain, and these biotechnology, and biomanufacturing, and cybersecurity, digital design, simulation and integration, energy storage, high performance computing, next generation computing, interface of things. Now previously we used to talk about Internet of Things. Now it is interface of things, and so on and so forth. And a vision in the sense of Industry 4.0 is to enable technologically complex systems to control themselves autonomously and behave more intelligently through digital algorithms, virtual models, and status information. No digital twin without digital thread. Digital twins still infants at infant stage, but with great promise as far as India is concerned. Digital twins are creating a Midas effect across industries, be it in optimizing automotive value chain or aircraft innovations or digital oil drilling models. Forward-thinking manufacturers are already benefiting from digital twins. For example, manufacturers of passenger vehicles create digital twins of the vehicles sold. While vehicles are simulated in factories, data transmitted via sensors from the vehicles on the road are interpreted by artificial intelligence to evaluate their functioning. Digital thread will be the needed robust geospatial infrastructure. Since a digital twin's success relies on the availability of data, insufficient data can make the models ineffectual. SMEs in many developed countries have progressed considerably in the adoption of smart technologies towards Industry 4.0 and Industry 5.0. Their successful manufacturing approaches manufacturing approaches like inclusion of partners in value chain, simple and effective ERP-centric approaches, open innovations, adoption of agile methodology, innovation labs for demonstration, multiple stakeholder approach, skill and talent development, and funding of digital transformation. According to Franklin Roosevelt, a smooth sea never made a skilled sailor. Franklin D. Roosevelt said, a smooth sea never made a skilled sailor. Digital transformation of small entrepreneurs and small businesses in India, challenges and opportunities. He delivered a talk on 19th June 2021 in this international webinar series. And some of the very important suggestions and recommendations emerged from this article, from this webinar series, which is now going as a policy paper from the university to the Ministry of Micro, Small and Medium Enterprises. It is very nicely said that most of the MSMEs are run by second generation or third generation entrepreneurs who are conversant with modern technologies, including digital technologies, while traditional technologies were adopted by the first generation entrepreneurs. The pertinent questions raised are as to why the present generation SMEs are not adopting technologies, why they are not getting such opportunities that the large industries are getting. What is stopping them? What is preventing them from adopting digital technology stacks to scale up their operations to the extent possible? From the Indian SLP's point of view, they have grouped the digital needs as per the following categories. First is infrastructure, desktops, laptops, internet, cloud computing as an OPEX, not CAPEX. Regulatory, that is their second priority. And taxation, EPF, and e-filling. transactional, ERP, point of sale, and bookkeeping, payroll, back office, email, Word, and spreadsheet, collaboration, Zoom, Team, project workflow, event management, branding, websites, channels, and content management, marketing and sales, CRM, distribution, online advertisement, e-commerce. Second, large. Then only comes product development, which needs, drawing, designing, and modeling. The last one is transformational, artificial intelligence and IoT analytics in Industry 4.0 and Industry 5.0. On the scale of a 9 scale, the product development and the transformational IoT, the industry information technology comes as 8th and 9th category. The suggested way forward is that use digitalization as an effective means to foster the growth of SMEs. Undertake inventory of modern industrial applications of countries' resource base at ISIC and STIC 5-digit level, at disaggregated level, that is at the production data and the trade data level. Develop, document, process, design, and market of products at the disaggregated level. Identify viable avenues by reducing the distance to the frontiers of best practices in process, design, and market at the disaggregated level. This is where that today's talk is going to be very important. Enhance adaptive technologies to use modern technologies to commercialize a new knowledge. Utilize government instruments, namely policy intervention, rendering technical assistance, business support services desk. Such instruments tantamount to babysitting, business enterprises. Establish institutional mechanism for information dissemination at village and district level. Promote cluster approach, for business to collaborate to compete, and use digital method for effective knowledge dissemination to correct coordination failure occurring in the cluster networking. And the framework for digital transformation of MSMEs towards Industry 4.0 and Industry 4.5 is an approach paper prepared by Dr. B. Balasubramanian. He talks about there are 13 key recommendations. Let me read it out. Reuse and share the digital infrastructure. Use solutions based on open innovative concepts. Collaborative with others in the ecosystem. Carry out capacity building on new technical skills and new business skills. Prefer manufacturing as a solution. Provision the funding and incentive, and drive the initiatives to be a dedicated establishment. Establish and use innovation labs, competence center. Use agile methodology in manufacturing. Monitor the progress of each individual industry. Include the purpose of digital transformation, and create and sustain, living conditions with decency for the workforce, and spread the industries to many other new locations for the balanced growth. There are two things which I would like to, expand as given in the note submitted by Dr. V. Balasubramanian. One is on collaborate with others in the ecosystem. Under this, he talks about leverage with the similar digital transformation strategies. Leverage. Collaborate with industry association like MESA, trade association, financial institutions. Partnership with the knowledge institutions like NIC, CDAC, and IT service providers, partners, and IT service implementing agencies. Partnership with industry business consulting agencies. Partnership with academic institutions like IITs, Indian Institute of Science Bangalore, ISRA, Indian Institute of Space Technology, National Institute of Technology, College of Technologies, etc. CITSA of Soviet Institute of Engineering Technology, PSD College of Technology, and etc. It also helps to explore new technologies like digital twins, while models and improves which models and improves the cyber physical system through students' projects and academic research projects. Very effectively said it. Let me now, and he also talks about prefer manufacturing as a, as a service to enhance the success rate of digitalization and other non-technical issues. Let me come back to give a brief introduction about CollabCAD, a development journey by National Informatics Center. Early 2000s, the computer-aided design group at National Informatics Center initiated on the development of indigenous and affordable 3D design and drafting software using open source tools and libraries, open standards, and open platforms. Strategic sector organizations like Baba Atomic Research Center, Open Mumbai, and the Department of Atomic Energy and Vikram Sarabhai Center Trivandrum of the Department of Space were onboarded on the development of CollabCAD to build the highly advanced CAD and the drafting system with product lifecycle management. Micro, small, medium enterprises of business is the high priority of government. 74th General Assembly session of United Nations in 2014, 17 declared the 27th of June as Micro, Small, Medium-Sized Enterprises Day, recognizing their contribution to sustainable development and global economy, and its theme for the year 2021 is MSME 2021, Key to an Inclusive and Sustainable Recovery. Achieving the sustainable goals and an economy that is greener and fairer requires resilient and flourishing MSME everywhere. According to an UN publication, about 600 million jobs will be needed by 2030 to absorb the growing global workforce, which make SME development a high priority for many governments. And this is an opportunity that, with this background, now let me turn to the address by Mr. Guntuku Prasad, Senior Technical Director, Scientist F, Head of CollabCAD Division, National Informatics Center, Ministry of Electronics and Information Technology, Government of India, on the topic Industry 4.0 in MSMEs, benefits of indigenously developed CollabCAD, 3D CAD, and PLM software from NIC. As per the synopsis of the guest speaker, NIC's CollabCAD, a collaborative CAD, PLM software technology, and also a web-based 3D viewer on NIC Cloud are going to play a vital role in MSME's digital transformation journey and educating the next generation of engineering students and professionals, Gen Z. This topic will motivate and galvanize the participants watching our telecast through facebook.com Shobhit University India or youtube.com Shobhit University for motivating them to establish Industry 4.0 tech-enabled digital twins startups to harness the power of transformers, technology, and capital to modernize the operations of small and medium businesses or micro, small, medium enterprises. This will lead to empowering India through Make in India 2.0 more vibrant. Let me assure you, the two centers of excellence, which are conducting this international webinar series on open source digital technologies for self-reliant India, Center for Informatics Development Solutions and Application, and Center for Industry 4.0 Technology Studies and Application, are capable to facilitate through skill and entrepreneurship development of rural youth with science, technology, engineering, and mathematics specialization of the country. The university is launching an MBA program on Industry 4.0 technologies for MSME sector from this academic year 2021. Let me introduce our guest speaker. Let me read his profile. Mr. Guntuku Prasad is the Senior Technical Director, Scientist F, Head CollabCAD Division, National Informatics Center, Ministry of Electronics and Information Technology, Government of India. He is a qualified civil engineering graduate with the distinction from Andhra University and postgraduate in civil engineering from National Institute of Technology, Varangal in 1992, and worked on R&D project on mapping of liquefaction potential in ground soil by analyzing engineering properties of soil in Delhi area. He obtained his MBA in IT from IMT Ghaziabad in 2008 as part of the Working Professional Program. Mr. Guntuku Prasad joined NIC's Computer-Aided Design Group in 1993 and worked in CSAM engineering analysis modules for offshore and building structures. He provided training on specialized models to industry and academic institutions. He was closely associated with Department of Rock Mechanics, IIT Delhi, in photon-based development testing of software for computer structures. Late 90s, he has undergone training with other engineers on the development and maintenance of ICEM DDN, a CAD CAM software at Control Data Corporation, United States of America, for its various customers across Europe and North America. The software was also promoted in Indian industry with his contribution in software development lifecycle. Mr. Guntuku Prasad, in the last 28 years of his service in NIC, had significant contribution in the area of software development of desktop and web application using open source software and tools in engineering graphics for education in industry. He had closely interacted with like-minded scientists and engineers in various government scientific institutions in building indigenous institute solutions. He is currently the head of the CollabCAD division under the education group and associated with various skill development programs for students, teachers, and engineering graduates. He is closely associated with popularizing CollabCAD. About 440 plus CBSE affiliated schools pursuing engineering graphic subject curriculum, and also under the Atal Innovation Mission's Atal Tinkering Labs 3D design for 3D printing project across 6,000 plus schools in India. Mr. Guntuku Prasad, we are very happy to welcome to this international webinar series on open source digital technologies for self-reliant India, Atmanirbhar Bharat. Very important topic, Industry 4.0 MSMEs. Benefits of indigenously developed CollabCAD, 3D CAD and PLM software from NIC. Over to you for your address. Thank you.
Thank you, Professor Moni. I appreciate the introduction and inviting me to speak on this international webinar series on open source technologies. And I also wish to thank NIC Training Division in permitting me to speak on this topic and contributions of CollabCAD team at NIC. Good morning to each one of you present today, and trust you and family are keeping safe and healthy. I feel honored and humbled to express my views on this topic, which would be of interest to all of you who are attending this session virtually on Facebook and YouTube. Thanks to all virtual participants and guests for spending some time with me today. If you have any questions or clarifications on the talk and CollabCAD software, feel free to type in the chat window or on the email. I shall try to get back to them right after the presentation and even offline mode. I would now share my presentation and time permitting, show some live CollabCAD 3D design videos also to keep the software features, technical features in mind. So I'll start my presentation. So the topic for my webinar, it's visible. I think the presentation is visible. Okay. So Industry 4.0 in MSMEs, micro, small, and medium enterprises in India adoptions of NIC's CollabCAD. It's a 3D CAD,
Mr.
computer
Prasad,
design. Yes,
Mr.
sir.
Prasad, there is
Yes,
one
sir.
thing called you hide that one. Stop sharing, hide. It is obstructing some portion in your slide.
Sure, sure,
Yeah,
sure.
okay.
Thank you, sir. Thank you. So the topic of my webinar, I think Mr. Professor Moni has aptly given a good background on it. And it's Industry 4.0 in MSMEs, adoption of NIC's CollabCAD, a 3D CAD and PLM software. I am working right now in the head of the CollabCAD division. It is part of the education group in National Informatics Center, New Delhi. So the topic for my agenda of topics, you can say, I'll talk a little bit. I'll touch some points on Industrial Revolution 4.0 and what are the digital technologies associated with Industrial Revolution 4.0. Some of the what is the role of the MSMEs in India and some of the challenges faced recently. Role of Industry 5.4.0 for digitalization in MSMEs. And I'll talk a little bit about what is CAD software and role of CAD systems, and then about CollabCAD and some of the objectives in development of CollabCAD and the milestones which we have achieved in the journey of CollabCAD. And finally, I'll talk more about technical features, 3D design features, and what are the product lifecycle management features in CollabCAD. And the new solution recently we developed is called eCollabCAD, is the cloud-based 3D web viewer. So this is the summary of points which I will touch, and hopefully it will be of interest to all of you. So as you're aware, the industrial revolution terminology has been evolving over last few decades. So we have heard about the first industrial revolution. It came with the advent of a lot of mechanization, which most of the facilities like mechanical production facilities were using water and steam power for manufacturing. It was started around 1800. Then we heard about the second revolution. It revolved around mass production and assembly lines using a lot of electrical energy. So similarly, third industrial revolution, basically there was a lot of advent of electronic and IT systems. It helped in further automation of the production. So you can say the first programmable PC, which came in 1969, started putting thoughts in the industry that how to use electronics, IT systems, and little bit of automation in performing industry. Then finally, the fourth industrial revolution, which is going on. It is the fourth wave of technology, you can say, that integrates the digital and physical worlds. So if you see Industry 4.0, it basically refers to the transformation of industry. So through the intelligent networking of machines and processes with the help of ICT and digital technologies. And it will continue to promote this increasing CAD/CAM computerization and integration of industrial systems. So we are hearing a lot of these new terminologies, especially technologies like smart designs and smart manufacturing, cloud computing, Internet of Things, data capturing and doing a lot of analytics, digital fabrication, which is a recent terminology which has evolved, that includes 3D printing. And most we are talking more as a cloud infrastructure is evolving. We are giving software as a service also. So there are a lot of new marketing models are evolving out of this, and embedding all these elements in an interoperable global value chain, which is shared by the companies. So we'll talk a little bit about the fourth industrial revolution, digitalization now. So there are a lot of things in the technologies which are all helping in the digitalization of industrial 4.0, which may be relevant to the manufacturing industry. So some of the things are like advanced robotics, where we talk about the industrial robots and a lot of integrated sensors and standardized interfaces, which help in digitalization. And recently we are talking about the second topic, you can say, is 3D printing, which is additive manufacturing technology. It's especially being useful for a lot of generation of, particularly for spare parts and prototyping. And it helps in decentralization of 3D facilities. So it helps in reducing the transport distances and the inventory also. Little bit then augmented reality, virtual reality, or called recently it's called mixed reality now. So it is used for a lot of maintenance activities, for logistics, and even for training. and it helps in lot of demonstrations, especially for supporting information of the products. Especially you see to use the glasses and all, it's all digital technology, which is used. A lot of research is being done right now in the academic institutions also. Then some of the things like industrial internet, which is all talks about networking of machines and products. So, and important is also we need to have a good cloud infrastructure so that you can manage the huge data volumes in using all open systems. And it helps in having real-time communication for industry, manufacturing, and production systems. Once you have the cloud infrastructure, we talk about cyber security. So all the networks, and we need to have open systems and high level of networking between intelligent machines and products and systems. So, and once you get all this data which is generated, we talk about now big data analytics helping the industry even in getting very good real-time decision-making support systems. So we should be able to evaluate all the data which is available from various systems like ERP, supply chain management, CRMs, and even from the machines. So these are some of the technologies which are evolving due to Industrial 4.0, which can help us in the SMEs also. So a little bit I'll touch about 3D printing, which is a hot topic right now. So we talk about traditional manufacturing where it is mostly subtractive, where there is a lot of wastage of material. So there are a lot of operations like drilling, turning, and shaping. So basically, if you have a building block and a machine block where you're trying to manufacturing a part using traditional manufacturing, we say there is lot of material. So advent of additive manufacturing has helped to fabricate a physical three-dimensional part from typically a CAD model, which is generated in a CAD software by quickly automating using a total flexible manufacturing process. So there is less wastage. So especially if you see the second figure, it says that there are a lot of layer by layer based manufacturing. And so there is less loss of material. So obviously you will get a lot of benefits of 3D printing. These are some of the benefits you can see pictorially we are representing. Making repairs are very easy, like automation and all. So, and even reduce the material wastage. So, and especially if you've seen for good, they are able to print also directly using the body parts, and a lot of localized production can be done. And so that it helps the growth of economy and logistics. It improves the logistics scenario also, and a lot of flexible and efficient manufacturing in the industry. And especially the most important part is reduced wastage. So we have a lot of less wastage of raw material. These are also being some of the technologies. I'll talk a little bit about virtual reality. It's all a digital technology, which is an interactive and you can say a believable virtual world, which is generated in a computer use especially. So where a user can explore and feel the real things using a virtual reality glass. So obviously, if you are developing this technology in a software, so you want the 3D image should change smoothly as you move your head, assisted with head-mounted display. And so it creates a realistic 3D perspective of the virtual world. So it helps in a lot of this simulation and training activities. So with VR, users can train in the dangerous and complex environments, practicing their skills before within the safety of a virtual world before you try to use it in the real world. Next, we talk about a little bit of augmented reality. It's all about, you can say, connecting the real world we experience to the vast virtual world of information that is available about the object, you can say the product. So with immersive design, engineers, designers, and even builders can quickly and conveniently digitally transform their CAD data into interactive real-time experience in a highly simulated digital world. So CAD models are effectively used to present your products also in augmented reality. So we can show the models of your design, plants, or even machines in meetings, or even sales talks. So if you see AR, VR, and MR, you can say, it helps you navigate easily to a data-rich design environment for making better informed decisions and creating a good experience about the product before it reaches the real world. Recently, we are hearing all this mixed reality. It's a combination, basically, you can say, where the user interacts with and manipulates both the physical and virtual items in a digital environment. Basically, there are a lot of sensing and imaging technologies are used to develop this software. So it allows you to see and immerse itself in the world around you, even as you interact with a virtual environment using your own hands, all without ever even removing your headset. So if you talk augmented reality, virtual reality, and mixed reality are changing how we design, create, and experience everything from product factories, buildings, and cars to training, even learning, and even for entertainment industry. So as we discussed this topic, we are talking about what are the role of MSMEs and what are the challenges, some of the challenges they are facing in this current scenario, especially in the pandemic scenario also. So historically, if you see, MSMEs in India have been contributing very silently, you can say, and effectively to the growth of the economy. And certainly digital transformation using Industry 4.0 is the step in the right direction. And with the, as Professor Moni told a little bit about Atmanirbhar Bharat, I should say that the vision of Prime Minister's Atmanirbhar Bharat and even the Digital India mission, there is going to be impetus on a lot of these digital technologies around Industrial 4.0, especially like smart design and manufacturing. We hear about IoT, Internet of Things, infrastructure being developed around it, and even devices are being designed keeping IoT. So, and even the cloud infrastructure is being enhanced a lot, and the 3D printing and AI-enabled systems. To basically, you have a lot of design data which helps you to predict how a next design can be done using AI. And so, if you see, there are a lot of challenges. If you can see, the industry is facing. I think being in a IT industry, I can foresee a lot of these challenges being happening right now in the current pandemic, especially remote working, you can say, or working from home. It's a big challenge for a manufacturing industry. So it's, and even it's tough to now find a skilled workforce when in the digital space in short period of time, because we are not sure whether they are efficiently skilled, especially in using digital technologies when they are habitual to the traditional manufacturing. So there is some loss of productivity as usual. There is efficiency loss also, and even the credibility of the industry happens. So, and it's also becoming a challenge to maintain the supply chain, even marketing. The team is affected, and accounting also becomes cumbersome. So you can say that lack of digitalization also makes the work more tedious and expensive to maintain. So certainly technology can help in the industry, MSMEs, to in this current scenario. So what can you say? How do you say that digitalization and improvement of ICT infrastructure can help in the industries? So we'll hear that there are a lot of ICT tools and infrastructure which can certainly help MSMEs, especially to reduce the costs and standardize the procedures in designing, especially, and even the manufacturing, and a lot of automate entire business processes, which happens once the product is released to the market. And so it reduces the reliance on manpower, especially wherever possible. You can use digital technologies to roll out quickly the industrial products in the market. And moreover, going digital, especially low-cost solutions, certainly help. So because a small-scale industry, usually they'll will be running short on budget. So especially low-cost solutions, including CAD/CAM systems, which are cloud-ready, will enhance the MSME's competitiveness and also understanding the consumer behaviors. And the current pandemic, if you see, and frequent lockdowns we hear regularly in the media also, that it has been a big challenge also to the manufacturing industry to keep their businesses running and even delivering the products. So it is, I think, imperative, I think we can say, to embrace digitalization in every aspect, wherever possible in the entire life cycle of a product, whether access to new generation technical talent, how do you build and manage the ICT infrastructure, and I also use the latest software solutions which are easily accessible and affordable also. So certainly open source solutions help in this regard sometimes. So we are helping to develop a lot of these solutions also. I'll talk a little bit now about what is the role of industry 4.0 for digitalization in MSMEs. So you can see one of the critical pillars of industrial 4.0 in the earlier slides. So it can be the starting point, I think, for a lot of these implementation projects. It's a low risk entry, basically. So once you have a digitization strategy, any SME can adopt these digitalization techniques in a phased manner. So if you see, the focus is basically to combine production, information technology, and the internet. Availability of these three things should help the industries. Digitization of all the horizontal and the vertical value chains, all the segments are helpful, and you providing the digital business models and customer access using digital technologies. Certainly, so digital transformation strategy will offer a lot of opportunities for growth and sustaining the competitiveness in the industry market. So a lot of this we hear about flexible manufacturing and improved logistic systems, and also offering interactive and collaborative decision-making mechanisms. These are some of the things we can say which will help in digitalization in MSMEs, especially so it helps in operational agility, and certainly cost is a major factor. So we have to be very cost efficient too. So to summarize this, these are some of the industry 4.0, what it can play a role in the digitalization in MSMEs. So now once you know here about digitalization, we obviously in a manufacturing industry, we talk about computer-aided design. It's CAD software is a technology. I think we all know that it's used for designing physical objects and helps in technical documentation in the form of drawings. So which replaces the traditional drafting. We used a lot of papers and all drawing sheets with an automated process. So basically, it's a use of computers and high-level workstations, you can say, to aid in creation, modification, analysis, or optimization of a design. This is very generalized definition of CAD. So we should be, why you need a CAD software, basically, what is the role of a CAD system? You should be able to create good 3D CAD digital models, and it should be 3D print ready. Nowadays, they say the CAD model should be 3D print ready. So we usually generate the STL format, which is the industry open standard for a 3D printer. And the technology, if you see the use of desktops the last 10, 20 years, and the cloud computing recently has been enhanced like anything for speed, especially scalability, and even the storage. Storage space has become very economical and cost efficiencies. So keeping all these factors, even the SMEs can really are migrating to all this desktop and cloud computing. And certainly the CAD softwares will give a better visualization, 3D visualization of the finished product to understand, and so reduces the high cost of developing a product, And once you're able to have a better visualization, it may help in decreasing the errors in production and design processes. So helps the improving the quality of the product and getting to the market very quickly. So these are some of the use cases where you can say the role of CAD software we are seeing in the industry, especially, and also in the education sector and knowledge building. And skill development is a major when the Skill India part and all. So we are trying to use a lot of skill development, especially school level also. Now people are aware of the CAD concepts, especially, and before they go into college. And once they are out of the college, they are ready for the industry also. And certainly in the industry sector, we have for the automotive, some of the application areas in aerospace, manufacturing, even for jewelry design, and even for toys, etc. And a lot of these academic courses for students and teachers and even for researchers. If you see recently, all the courses are well tuned in covering the CAD part in their academic syllabuses. And certainly, if you see hobbyists and professionals, they are every time playing around with a lot of open source technologies in the CAD area also. So now we'll talk a little bit about CollabCAD. I think NIC being a premier government organization delivering a lot of e-governance solutions across the center as well as in the state governments. Also, computer design group was doing a lot of research and development work, and even developing a lot of indigenous engineering design solutions even for analysis. And so we developed this 3D CAD software. It was developed on basically Linux platform, and it's available basically on Windows and Linux based operating system. It's a collaborative initiative, you can say, with, as Professor Moni had told in his inaugural introduction. We had started with the computer division of Baba Atomic Research Center and the mechanical CAD division at Vikram Sarabhai Space Center in Trivandrum. And we have used purely open source technologies which are highly reliable and mature and stable, and which are already upgraded as soon as possible. So we have used a lot of these tools in building CollabCAD, which is called collaborative CAD, computer design. So it has been useful for developing for product design also. Little bit about CollabCAD. We have a lot of this product lifecycle management strategy, and we have developed a lot of tools which helps in the lifecycle management. Especially if you see the design lifecycle management, we take care of a lot of these solutions. It's slightly coupled with the CAD part, where once the part or assembly is designed, we manage the life cycle using the PLM strategy. So an enterprise, even an automated application is available, which comprises a lot of these modules, tools for ERP, CRM, and supply chain management. So the design, basically, once it is done, you can say it can be saved on a local system in the standalone mode or in the remote server while using the client server mode. And even we have the user can maintain the design parts in a content repository system. You can say it's on the web server or on a cloud anywhere. So that additional facility is there. So to build that solution, this tool helps you. It provides an interface, you can say, to the open source content repository system, and certainly incorporating security, locking, and versioning of the engineering drawings and documents. And there is a web client also for that, for management of files, creating users, access control of the repository is very secure. And even files such as Word and PDF documents also can be checked into the repository. A modern browser can be used to access this file server, especially, or also to view the files. The CollabCAD journey, if you see, we have achieved some milestones. You can say it started in collaboration with BRC and BSSC. We had collaborated with tool rooms, which are started by MSME, especially in Aurangabad, Kolkata, Ahmedabad, to connect to the SMEs nearby the training institutes. It was part of the PG diploma program for CAD training. CollabCAD was taught to a lot of students in a 3-year period. So we have been providing them support and training and providing them resource materials in and troubleshooting also. So occasionally, so they have been very cooperative in popularizing CollabCAD in their training programs. And recently, as the cloud technology was evolving, we had developed this 3D web viewer using open source technologies, and it helps in uploading, sharing of 3D design data onto the cloud, and this is deployed on the NIC cloud. We are also part of the National Knowledge Network, which is connecting a lot of engineering colleges across the country. The software is provided to a lot of these colleges who are part of the network. To popularize this CAD concepts according to the school students, there is an interesting project going on at Atal Innovation Mission. It's called the Atal Tinkering Labs, and they have a Tinker for Home campaign, 3D design for 3D printing. So there are a lot of 3D printing labs in the schools. So they use a CAD software called CollabCAD for creating 3D models and uploading onto the NIC cloud for sharing. So then they print it on their local printers available in their printing labs. So NIC CollabCAD provides the 3D design part software support to the students from class 6 to 12. We had a lot of periodic training sessions. Webinars have been conducted recently to generate interest among the students to understand CAD also. So this collaboration is going on with NITI Aayog. We have released a lot of these ebooks also and tutorials which are available on the CollabCAD portal. Later, I'll show you how to use that CollabCAD portal. And another thing was we recently signed an MOU with the Central Board of Secondary Education, where one of the subjects in class 11th and 12th is the engineering graphics. So, and part of the practical curriculum, students are supposed to create projects on a lot of 3D design, you can say CAD, especially machine blocks, even basic tutorials like creation of all the engineering drawing views using the CAD software, CollabCAD. And there are a lot of tutorials available also. We have regular training sessions with the teachers, subject experts, and we are preparing research material, training materials also for them. So the students are continuously upgraded on the usage of the software also. So these are some of the milestones you can say. So this is a brief summary of the CAD features, you can say, the 3D design features and modeling features, which a 3D design software which is available in the market usually has. You can do surface modeling, build surface models from a lot of these geometries, even solid models. It's a hybrid modeler, you can say, where you can do both parametric and CSG based modeling. The geometry is stored as a boundary representation, you can say the BREP format. So there are a lot of options where solid modeling features are available. Finally, when the part is designed, when you have more than one part, you can use the assembly design module to assemble all your parts and complete the assembly. And once the assembly or a part is designed, you need a 2D drafting module, the plot configurator it is called, to generate the engineering drawing views like front view, top view, or the section views. You can generate the detail views and even generate the title block and even connect it to the plotter for printing. And one of the useful features, which is very useful right now is the collaborative design, where it's basically network enabled on a local network in a secured network. More than one designer can work on the same part, and you can create, edit, and modify the part design. So it's a very useful feature, especially in a collaborative environment. And we are supporting all industry standard open data formats, which are like IGS, it's a surface are exported. STEP is a very useful manufacturing industry standard. STL is a very common 3D open format, stereolithography format. We support both ASCII and binary. PREP is for the data structure. Basically, you can say it stores all the faces, vertices, and edges data in a file. So these are useful for data exchange to talk to different CAD systems in the market. So especially for the 3D data. 2D, we have DXF. It will be supported shortly. So once your 3D model is ready, right now, because for 3D printing, it's very useful that 3D CAD software exports into STL format, which is again read into a 3D printer, which basically generates all the layers by layers. It does the analysis and generates the model onto the printer using the layered technology. It's called additive manufacturing. So CollabCAD supports this STL format, so which is compatible with all 3D printers, and it has been tested also in a few locations for the 3D printer. So these are some of the additional features in CollabCAD CAD software. It has a 3D canvas for visualization of all your 3D models. You can generate a lot of curves geometry, both 2D and 3D, like all lines, arcs, even ellipse, conics, and even splines, Bezier curves and B-splines. And you can generate polygons, combinations. You can generate a lot of and another important feature is you can generate a 2D sketch using two-dimensional constraints, geometry constraints, and distance-based constraints. You can complete a full 2D sketch from which a solid can be generated. So 3D part and assembly design is a very important module, surface modeling and solid modeling, which I talked earlier. And automation for like if you know programming in Python, Python is a Java implementation of Python. You can write a lot of automated scripts which will help you in generating a lot of standard parts, you can say, and which are regularly you generate designs. It's a very useful interface to who are conversant with programming. And our GUI is highly customizable. You can for menu bar and the toolbar. And as you stated earlier, we are supporting industry standard open data exchange formats. And once your 3D part is ready, you need a plot configurator which to generate your 2D engineering drawings. So here it's a very advanced 2D modules where all the section views can be generated, detail views, even you can generate detailing using dimensioning, standard dimensions, horizontal, vertical, inclined, aligned, all the dimensions. And even the title block and bill of materials can be generated. So once your all the design documents are ready, you can say the design data is ready. You can manage in a PLM software also the module which it's already available in CollabCAD. Collaborative designing, I told it's all network enabled. Whenever you want to work on a team of designers want to work on a single design, they can use the collaborative design module also. These are some of the components which we have modeled in our software. These are all machining components, so mechanical industry. So a lot of models are uploaded onto our shape gallery also in the CollabCAD portal. These are the assembly model, press tool assembly. Even a spanner set is there. It's a camera block, you can say here. So these are all colorfully generated in the software also. There are a lot of features you can play around with the color of the entity also. This is a sample output of the 2D drawing. It's of a machine block. So you can see here it has the front view, right view, and the bottom view, and the isometric view. And some minor detailing is done. Even the title block is available. So this is a advanced module, another for generation of 2D drawings from the 3D part. We have an online web help also. The product help entire document is available, easily available on the browser also. You can browse online all the system requirements. The entire user's guide is available online also. It's also bundled with the software also in the desktop version. So this is you can choose your language also, all the different versions, and the modules can be browsed at per convenience. Now I'll talk about one of the important tool which we have. It's a very useful tool recently because of the advent of internet. We have developed this cloud-based 3D viewer. It's called CAD. It's a product for any geometry mesh visualization, including CAD data. You can also open 3D formats like STL, OBJ, PLY. VRML is for virtual reality. MUZ is the CAD data. JSON is another CAD data which we are using for the cloud. So it's a product. It allows uploading and sharing also, which is a very useful feature right now. The industry can very much use it for sharing of 3D design data on the browser. But you have to create an account. Account is right now free. It went live in 2019 for the public. You can say it's like a social media account, with like for the engineering data, something like that. So you don't need to install any extra software, you can say, or plugin to view this 3D data on the fly. So it's available. You can have your own private gallery or a public gallery. You can share your data onto the public or keep it in your account also. It works on all desktop. It has been tested on all desktop and mobile modern browsers. Because all modern browsers are supporting WebGL, industry standard, and HTML5. So it helps in basically visualization of the 3D data on a browser or a mobile browser. So how does this work? Basically, the CAD 3D viewer. Once you're on the CAD portal, you need to register first for a new user. And once you register, you can you have this interface here, which helps you to upload, view, and share 3D models. So this is a snapshot. If you can see, these are the currently list of models of that user. He has uploaded a lot of OBJ files here. So once he uploads, he can online visualize simultaneously on a browser window. And if he desires, he can publish for the public to see. Otherwise, he can keep it in his private account. So this is if you see, this is the interface for the login to the email account. CollabCAD account is now a one-stop account for accessing CollabCAD resources. So these are some of the technical features of the 3D web viewer. 3D visualization on the browser. Any browser we have tested on all modern browsers like IE, Internet Explorer, Google Chrome, Firefox, and even Opera. So you can upload or share these 3D models. And once the 3D model is available on the browser, you should be able to render it. So we even show the wireframe model, even the mesh model, even shaded model like with facets. And you can have a sectioning view also. You can clip a 3D model also. And you can simulate a 3D environment mapping also. So how the product looks like in a 3D environment. And the basic primitives also you can create for education purpose. Students can learn what are the different types of primitives. So main criteria is you don't require separate software installation. It runs on the fly on the browser. So this is something like a summary of the 3D viewer. We have the model tree. we have the different views, which a typical CAD software also has the views, primitives. This is the visualization options for rendering. You can have a smooth, flat view, wire mesh, textured. Even you can do a lot of measurements like distance calculations. Even you can have a bounding box. I think it's here, the bounding box you can see below. This is the sphere which is shown, the surface normals are displayed. This is for a metallic finish. So the shading you can see how to. This is the fourth one is the sectioning and clipping. You can cut a solid or any part. And this is for the light simulation, the shaded view, and the shadow object also. So you can apply materials also, different types of materials you can choose as per convenience. You can give a color to the geometry. You can choose your background color, and especially set up a light environment using a lot of ambient features, point lights, directional lights, and all the clipping features are also available. You can set your clipping angle and rotation. This is a sample output of a 3D part, you can say a screw part, which has been uploaded onto the 3D viewer. So the entire interface is like a CAD software only. So you can play around with this and share the model to your stakeholders. This is just a small simulation of environment mapping where you can. This is the Jeep model which has been modeled in CollabCAD and uploaded onto the 3D web viewer, and we have created around a scene, around 3D scene for mapping. So you can control your camera angle, both orthographic and perspective projection. So you can move around your camera and translate the model also. This is the structural model of the Taj Mahal, which was designed, created in CollabCAD, and the model is right now uploaded onto the 3D web viewer. So it can be a useful presentation tool also. For this is the wireframe model, you can say, and the shaded model. The similar features are available in the CollabCAD standard desktop mode also. The same features are available. So just to summarize, some of our partners and stakeholders who have helped us in the journey of CollabCAD, we should thank Vikram Sarabhai Space Center, their engineers and scientists at even BRC, who have helped us in the development of all these specialized modules in enhancing the CollabCAD software, and Atal Innovation Mission for promoting to students. Now CBSE has been a very important part holder. We are closely working with that. Even we are trying to promote now even in engineering colleges and for the syllabus in AICT colleges. Hopefully it should be a useful tool for the students for popularizing the software. As usual, we are part of the National Normative Network, and to connect to the MSMEs, we have tried to be part of their programs at some of the tool rooms. So we hope to popularize it more in their tool rooms training programs. Thank you. So this is just a small, you can say, I try to cover this thing on the this is our URL, collabcad.gov.in, and if you have any email, you can write to collabcad@nic.in. So little bit I'll show how to now download. I'll just show you the CollabCAD portal initially for a few minutes, so that you can get a feel how to download the software once you create an account. I think I can share the screen also of the same.
You go to the share mode and no, it's not visible. It came and gone. Now, okay, it's coming. No, it is. You click that. Okay, good.
So this is our one-stop entry point, you can say, for all the CollabCAD material resources. You can say collabcad.gov.in. This is the landing page, which gives you all the information. So This is a recent session we had for the ATL students. We had a live designing and 3D modeling. So it has a lot of features about how to CBSE corner is there, Atal Tinkering Lab, how to download the online web help link, and I'll little bit scroll down. So this talks a little bit about CollabCAD, how to download. This is online visualization, you can say, and some of the models, shape gallery, the recent news, the talks about features of CAD and how it works. So once you log in, I'm already a registered user, so I'm just logging into my account. So this is the dashboard. You can say how many users are there right now. Recently, in the month of January, we had given a ebook on CollabCAD, which is a comprehensive guide for the students and even for the professionals. It tells you how to create 3D parts. So if I come here, we have this library. It's called the public library. This shows the history of people who have uploaded onto the portal here, NIC Cloud. So these are the last one is somebody has modeled a fidget spinner. Sri Hari 123. I'll just click on the. If you click on the 3D view, it is loading the model on the browser now. So this model has been designed in the CollabCAD desktop software, and he has uploaded this model onto the browser. So this is a user interface. You can interact with that. So I applied some small textures. This is the model tree. It shows what are the entities, right now information, what is the file type. So these are some of the things which we have. So similarly, here we have option how to download CollabCAD. Once you go to the download page, if you are a registered user, you will get options to download the CBSE version. For general industry people, they can download this 2.3.0, which is the public last stable version for them. So they can download for Windows and Linux. It has been tested on various Linux operating systems, especially open operating systems like CentOS, Fedora Core, even Scientific Linux, Ubuntu, and Mandriva. Mandriva is maybe Ubuntu we have tested now. Still, so a lot of versions it's available. You can use Linux also. Windows obviously on 10 it works. Even on 8.1, even 7.0 it still works. So we are providing regular support on this. So students are so there are even helplines are available. Email address you can contact for ATL students. General people can write to collabcad@nic.in. So this was recently last we had done this 3D design challenge for students. So these are the list of winners, you can say. So once you're if you have this is the file upload model. Like in my account, I have this files here. So you can browse the model to upload. Interface will come locally. File you can upload, and it will be uploaded to the cloud. So you can later view it or share it to the public also. Once you share it to the public, it goes to the public gallery. Even you can, this is a shape gallery, you can say these are some of the components which we have designed in CollabCAD and uploaded as a, these are images only. You can see the 3D view also. This is a small model of a drone done by some student. It has been uploaded. Anybody who has interest, you can browse through. A lot of assemblies are there. Even parts are there. They are all useful for the industry, especially manufacturing industry. Even surface modelings like we have done. I'll just show a small video. This video will try to show how software can be used. You're able to see, sir? This is a small example of a coffee mug. This is our interface, basically how the part design starts. This is our interface. You have to select your view where the sketch has to be made before it goes to. He's creating some small arcs. So these are the steps. So how do you create an arc from a radius and a center? So now once your arc is ready, you're trying to create a solid out of it using the extrusion option. So you give some thickness to it. So now he's rotating the model dynamically. You can use the keyboard shortcut keys also to play around with the 3D canvas. He's now creating one more arc. So we need some points also. So these are some of the steps where you generate the different, now he's trying to create the handle to the mug, the cylindrical portion. We are using some operations in the solid modeling, different operations are there. So we generate the sweep path to create the, once the arc is created, it gives the handle. There are a lot of menu, the top menu, the edit operations. Now we'll apply some thickness. We'll try to smoothen the cylindrical portion of the cup. Basically, you're trying to union now, combine both the objects here, the handle as well as the cylindrical portion. Now we are smoothing the edges. So he's selecting the edge there. So he'll try to smoothen that edge where it is transitional area with some small radius. now it will be smoothened. Something like a fillet, you can say, or a blend. You can play around with the views, front view, top view, isometric view. So all orthographic projections of the 3D model. Now is dragging the canvas mouse. Using the mouse, you can move the canvas. Now we'll make a hole here to make the cup hollow. Again, we are going to smoothen the edges here. So select the outer edges and the inner edges with some small radius. Similarly, you have to do on the bottom edges. So this is the wireframe, you can say, wireframe display of the 3D model. It's trying to hide the global axis. Now we'll give some rendering feature, shading the 3D model. The default color is blue, so the blue color, you can modify the color anytime as per your requirement. Even you can set the material properties. Here is trying to change the color now from blue to some other color. The color palette is popped up, so you can select your desired color. This is now looked at. Coffee mug is completed. So I'll show maybe another small one. This is maybe one more small, another interesting part I'll show. This is our CollabCAD, you can say the official logo also. Again the same, we'll just I'll try to stop this.
Mr. Prasad.
Yes, sir.
We will, I think it's now it's very effective. And how much time will it take, this one?
No, this is I'm just checking. Is it the same one or this is also few minutes? I'll just show it. This is a small we did for the school students, the Rubik cube. So this is also a 3D model. These are some of the steps you can say. You can create a box. I'll just drag it also, no problem. So the different steps are there in creating the Rubik cube. You can say you create a box and chamfer the edges. So all this is part of the CollabCAD part design mode. Setting up some colors. I think I'll stop this and maybe if you want, I can show one small, the 2D module also, the drawing module. Just a second.
I will request Dr. Balasubramaniam to join in while. Dr. Balasubramaniam.
Yes, sir.
Yeah.
Thank you for the invitation, sir.
I think most of the videos are available online also. We have uploaded a lot of videos on the NIC YouTube social media accounts. So we are preparing a lot of tutorials for the students, especially in customizing for the industry as well as for academicians also. So even we are trying to promote for the research also. So I think it's very imperative that we try to connect to the industries now and how to promote the software for especially small and medium scale enterprises where the parts are very small and easy to design also. Thank you, sir, for giving me this
It's very
opportunity. I hope.
nice, Mr. Guntuku Prasad. And I have got more insight about the project and the research work, developmental work, which has been done by the CollabCAD division of NIC. I got more when after my now than I was in the service. It was very nice that it is a lot of developmental work which National Informatics Center is doing it. The CollabCAD division is doing it, and it is a wonderful presentation for the benefits of MSMEs to usher in Industry 4.0. Now I will request Dr. Balasubramanian. He was also involved in CollabCAD activities when he was in service. Now he is very much effectively involved in creating a framework for digitalization of MSME. So I would like to request Dr. Balasubramanian very, briefly that what is the way forward from the talk of Mr. Guntuku Prasad uh, to the MSMEs. Over to Dr. Balasubramanian.
Sir, thank you for the invitation and thank you for the permission to share my views. And it's a wonderful session by Mr. Prasad. He pointed out various salient features of the CollabCAD, especially it is very much suitable for this webinar series because webinar series is pointing towards the self-reliant of India. CollabCAD was developed or it was initiated by National Informatics Center as well as Department of Space, Department of Atomic Energy long back in the same direction, that is towards self-reliant in technologies. Therefore, now Mr. Prasad has presented the recent additional features. This is very impressive, and especially it's very valuable tool for the MSME industries as well as educational institutes. Therefore, here we have to see the future direction. Since it's developed by NIC with the collaboration of VSSC and BARC, and we need a sustaining roadmap. My observation is it's better to develop a collaborative development model with the participation of IITs, IIScs, PhD, and premier institutes like PhD, Soviet University, and as well as national Institute of Technologies, NITs, they can also join the development, and similarly we have to involve the industries in supporting the that is support industries to propagate this cost-effective solutions to MSMEs, since it has to reach all MSMEs throughout India. It's a very valuable tool, as pointed out by Professor Moni sir. Yes, India is in a transition phase. We have to adapt the technologies to move forward, as well as to retain our position in the manufacturing side. And here we have to go for digitalization. That is the only way option. No other option, I believe. And as you also pointed out, sir pointed out, uh, the digital twin, especially in the era of Industry 4.0, is going to play a major role, especially for the students and researchers. You please consider this point, digital twins. Especially digital twins, there are many definitions, but for the manufacturing industries, uh, just we can recollect, we modeled the basic concepts during our designs and manufacturing. We modeled the basic shaft as a single spring and mass. Then later we extended the same model into a simple beam concept, and applied the load or torques, and see the behavior of the things. But in the same fashion, the digital twins gives an approximations for the realistic engineering or mechanical manufacturing equipments and machineries, components in the shop floor. Therefore, the all this Industry 4.0 technologies help us to close the matching. That is, it it, it reduces the gap between the real models and the virtual model, whether we are using IoT or various big data analysis and big all these things are helping us to reduce the gap. That means we are becoming or we are producing better model to utilize the outcome from the manufacturing components. Therefore, we need not physically manufacture any mechanical component, but we can simulate and see the entire life cycle using Industry 4.0 technologies. Therefore, all the students and researchers, they have to keep in this mind. The roadmap, we have to establish the collaboration between academic institutes as well as industry support industries to sustain this development in the long term. And further, while going in this collaborative software development model, we have to stick to the open standards. As pointed out by Mr. Prasad, it is the CollabCAD software has various open standards like STEP, IGS, VRML, and so on. Any other new component added by other educational institute or industries should also follow the open standards. We have to make this as a basic requirement, and we have to use or we have to use the open source libraries as well as open source software like ERP solutions. Mr. Prasad has pointed out the collaborative nature of the ERP software. Therefore, at the same time, one designer can share the model with various partners throughout the world, sitting across the countries. Just you need only the internet. This was established by the CollabCAD very long back. Similarly, And the best feature of another best feature of the CollabCAD is the 3D model is the core concept. Whereas many other software started with 2D models, plan, elevation, side view, and so on. Whereas CollabCAD started with 3D as the core concept. Therefore, it has various advantages since now we have to go in the industry 4.0. Therefore, our modeling will be very easy and we can easily share our model with various other utilities like your ERP solutions or product lifecycle management solutions, because it has all the open standards components like Mr. Prasad said, in the browser itself you can see the this component, 3D component using WebGL thing. Therefore, this adhering to open standards as well as open source solutions while extending these solutions with the help of educational institutes as well as industries, it's another core requirement. We have to stick to open standards and open source solutions. This is another basic requirement of our roadmap. Similarly, and somebody has to maintain the software through software practices. Therefore, we need the help from NIC, especially NIC has various wings, especially for software development. Developing the core feature is one thing, and sustaining the development through the build processes. Build process is another major requirement, and we have to automate the build processes. Therefore, here also the National Informatics Centers another group. It is called Open Technology Group. The help from them is also very much required to build the automatic or to automate the development process. Therefore, once the scripts are developed and for the automatic release of the build periodically by integrating the various modules through the test procedures, automated test procedures, this also should be kept in mind in our roadmap. That is, automatic build processes are to be inherited with the help of Open Technology Group of NIC. And here, the once again, I'm coming to the standards. Why standards are very important, especially for manufacturing industries, are very most of the industries. Uh, Here, as pointed out by Professor Sir, there are digitalization involves two components or two subcomponents. One is IT related technologies. Another one is, that is, IT means in the information technology related thing. Second one is OT. It is called operational technologies. Operation technologies like in the floor, shop floor, we have various machines, CNC machines, or so many machines are there. Welding machines, or cutting machines, boring machines, grinding machines. All these things are integrated. Then only the Industry 4.0 can be effective. For the integration purpose, that means any component can talk to any other component. Therefore, here also open standards are very much needed. The OT component, that is operation technology, it's not frequently changing. Whereas IT, once in 3 years or 5 years, you can see new set of technologies you can observe. Whereas the operation technology side, you need a large of investment. Therefore, investment in the machineries, equipments, and plant layouts, and sustaining all these things, it's a huge investment is required. We can't change this environment frequently. We have to sustain this environment very long, for a long duration. Therefore, here also we have to stick to open standards. Though there are many formats available for the Internet of Things, IoT, here also open standards are there. Similarly, for integrations, machine to machine communication, there are many uh, open standards as well as non open standard components are there, but we have to stick to only open standard based communication for the machine to machine integration. Therefore, we can preserve our investment for a longer duration, and we can sustain our solutions for a longer duration. Therefore, in the industry 4.0, we have to keep all these things in mind, and then only we can integrate all these components to to achieve our self-reliance in manufacturing as well as for the MSME requirements.
Dr. Balasubramanian, it's
Uh,
hello.
sir, yes, sir. These are the major points. Uh, we have to sustain we have to sustain using the open standards, open source solutions. These points are to be incorporated while making a roadmap. And I request Professor Moni sir to include all these key points while submitting this proposal to Ministry of MSME. Thank you, sir.
Thank you very much, Dr. Balasubramanian, for taking your time to participate and intervene in this very important webinar on the topic Industry 4.0 in MSMEs. One is that we had a very important presentation by Mr. Guntuku Prasad on what NIC has achieved, what CollabCAD has achieved, and it's a very important development journey that now working in 6,000 schools. It's a very important thing that catch them young and tell them that how to get into building models. And it's a very important journey. And you also very rightly said it that, it is the challenges are too much. The same time, opportunities are is there. Then in IT as well as in OT. OT is very important because mission to mission has to talk, because they are not going to change with respect to a particular manufacturing industry is concerned. And this mission to mission interface through open standards is an important thing. This is where that the academic institutions and research bodies like National Informatics Center and the centers like CITSA and Industry 4.0 technology studies centers throughout India and throughout the world have to talk together, get integrated through a very collaborative manner using open source technology. I am very happy that I'm able to host this talk, which should have taken place in the month of February, but it is taking place today in July first week, July 3rd. And I continue to interact with both Dr. Balasubramanian and Dr. Sugas and Prasad, and let us see to that this gets converted as a diploma program or certification program from these two centers of excellence, Center for Informatics Development Solutions and Application and Center for Industry 4.0 Technology Studies and Application, because this university is located in Meerut, and Meerut is an industrial town. And this can be a very good launching site to get into the Meerut industrial town very effectively. And we're also trying to do with the help of Dr. Balasubramanian. He is based at Coimbatore, and it is even though we are after our retirement from the Government of India National Informatics Center, we continue to work with the developmental aspects of what we have left. It is an unfinished task which we were not able to do when we were in the service. Now we continue to do through our academic involvement and research involvement and industry involvement. Thank you very much. And this 1 hour the almost 2 hours interaction will, galvanize the participants, the youths, to get into establishment of or establishing deep tech startups in Industry 4.0 to facilitate Make in India 2.0, that is MSME 4.0. Thank you very much, Dr. Balasubramaniam and Mr. Guntuku Prasad, and also your team members of National Informatics Center, for this wonderful achievement which has been done so far. Thank you very much. And with this, I thank all the participants and the Honorable Chancellor of the University and His Excellency, the Secretary General Ardo, for initiating this wonderful international webinar series on open source digital technology for towards self-reliant India. Thank you very much. With this, we will close the webinar and leave studio. Thank you very much. Thank you. Thanks for your participation and greeting from Shobhit University. For more research enquiries, please contact Professor Moni Madaswamy, Professor Emeritus and Chairman, Center for Informatics, Development Solutions and Application, and Center for Industry 4.0 Technology Studies and Applications, and former Director General, National Informatics Center, Government of India, New Delhi. Email ID is moni@shobhituniversity.ac.in. Thank you very much and good day. Leave studio.